Welcome to a brand new kubucation video, and this one is an exciting one. And not just because it took me almost 2 weeks to record a new video since the previous video, but because today we want to fully automate obtaining TLS certificates with Kubernetes and with cert-manager, but this time we want certificates that are accepted by the browser. So we want valid certificate using Let's Encrypt. In the previous video, we've already touched upon cert-manager, but we've used our own CA to sign the certificate. So we had self-signed certificates, and while that worked, it was fully automated already. They're really only good either for testing or if all your consumers are aware of this CA and are accepting this CA as trusted. But a way more natural use case is, of course, to have end users who open your page with their browser, or even if it's just an API, and they don't want to add a specific CA, they just want a generally trusted one. And Let's Encrypt is such a one, so let's automate this completely in this brand new video. So usually in my videos, I like to use Minikube so that there's no effort involved whatsoever. Everyone can get started. You don't need any accounts anywhere. But today I'm actually using GKE, so the Google Kubernetes engine. And the reason for that is that I want to get a browser trusted certificate, and that means I need to prove to the certificate authority that I actually own this site that I want to get a certificate for. And that is, of course, much easier if my site is reachable from the internet. So I've registered a static IP address with the Google Cloud Platform. This is this one, the kubucation test right here. And as you saw previously, I'm already running this Nginx server, and today I decided not to just use the Nginx default page, but to put the title of the video here just to make it a bit more interesting. And just to show you what's going on here, I've created a namespace. This namespace is called YouTube Let's Encrypt. And here's a handy little trick. If you already know that you're going to keep using a namespace, it makes sense to add this namespace to your kube context. And I have an alias for that. Mine is called KCN, that is Kubernetes Context Namespace. And what this does is basically it sets the context and obtains the current context and then just sets the namespace. So I can now do a KCN YouTube Let's Encrypt here. And now if I do a kubectl get pods, for example, I can see the pods in this namespace. So here you see what I already have running. There's an Nginx pod. This is this app here. And of course, it's exposed via a service. And then there's an Ingress. And this Ingress, this is where it gets interesting. This Ingress here has a reference to that static IP that we just registered. Where is it? Down here, Kubernetes IO Ingress global static IP name, kubucation test. So that is what we have. Also, I have already installed the Kubernetes cert-manager, and if you don't know how to do that, just check the previous video in which we used our own CA to self-sign certificates, because in there I'm also explaining how to install cert-manager with Helm. So just to prove that, if I do a get CRD, so get custom resource definitions, I now have a couple of CRDs here that I wouldn't have with just a bare Kubernetes cluster. I have certificates, cluster issuers, and issuers. And that's also the perfect place to get started. At first, we need an issuer. So if you remember from the last video, an issuer represents an entity that can issue certificates, as the name implies. So what we want to do is create an issuer for this entity. And this entity in our case is the Let's Encrypt ACME API. And if you read the docs there, they really encourage you to use their staging API first, because there's no rate limits just while you're trying out. And then if everything works, you can move to the production one. So that's exactly what we're going to do. Let's create a Let's Encrypt issuer staging.yaml here. And in there, we, of course, as always, need the API version. And that is, in this case, cert-manager.kates.io/v1 alpha1. So alpha here. So the API can definitely still change. The kind is a certificate. And as always, we need metadata. And we have a name here. And no, wait. Certificate is, of course, wrong. We want to start with an issuer, we said. So sorry about that. Now we have an issuer. And we want to give that issuer a name. And that would be Let's Encrypt Staging for now. So other than the metadata, there's, of course, the spec, and I don't know why this was indented like this. It should be like this, really. And the spec here is ACME. And then we have the server URL. That is HTTPS acme-staging.api.lets encrypt.org/directory. And we need to specify an email, because if we register with the API, we need an email. And for that one, I'll use my own and just append something, YouTube test, just so I know later what I used it for. And then we need to create a private key secret reference. And this is the secret that when we register here, we get a key that we can use to sign in the future. And that should just be called Let's Encrypt Staging, just like the name of our issuer that we have here. And of course, this should be prefixed with name, so it's valid YAML. Other than that, we need to specify that we want to do the HTTP 01 challenge. And if you don't know what the HTTP 01 challenge is, we'll get to that a bit more when we issue our certificate. But basically, as I said before, we need to prove to the ACME API from Let's Encrypt that we actually own this domain that we want to request our certificate for. And the easiest way to do it with the HTTP challenge, which basically just means that the API will contact our site on a very specific URL, and then we will provide a key at that URL that only we could know. So my linter is complaining here, probably trailing space exactly, and also at the very beginning, as always, I'm missing the document start. So we've created this issuer, so let's apply this issuer. Cool, there it is. So if we now do a kubectl describe issuer, there's only one, so that's why the describe worked. Then we should see here, where's the status? Don't have any yet. No events yet. Maybe if we do a kubectl get issuer instead, maybe we can see a bit more there. Basically what I'm looking for, some confirmation that we have registered against this issuer. And I'm currently not seeing that, so that could be an indicator that something went wrong. So let's maybe check the logs of our cert-manager, which is running in the kube system namespace, I believe. There it is, and let's just see if it has logs. And for logs, I have this KL alias, which is kubectl logs, and then kube system. And we need to specify the container. That would be cert-manager. Okay, it looks like we have an issue here. So this would be much nicer if we would have seen this in the events column, but apparently right now the only way to get to this issue is to check the logs. And this was, by the way, not planned for. So requeuing item, due to an error processing ACME server, private key and email are required fields. So it looks like we missed a field there somewhere. So let's check our issuer. So spec ACME server. Ah, there we go. That's a typo. We don't have a private cray secret ref. Private key secret ref. Cool. Okay, so now that we have that fixed, hopefully if we do a kubectl describe issuer, let's encrypt staging again, we should now see still no registration. No, wait, I changed the file, but it didn't apply it, of course. How would it know about it? Okay, so let's apply this file. Okay, and yeah, if I only edit the local file but don't apply it, that's not going to change anything. So let's see what our describe, just go back in our history, describe issuer, what we get now. Now we have events. Okay, error verify account, fail to verify, okay, warning, error initializing, no such host. Okay, so there seems to be another typo. So let's check this again. Let's encrypt really should only have one S, I believe. And again, this time I will apply it directly. And let's check again for our issuer. The ACME account, so this is what I wanted to see initially. Here, the ACME account was registered with the ACME server. ACME account registered. Cool, so now we have an issuer and we have registered for that issuer. So now that we have an issuer, we need to create a certificate as well. So let us create a new certificate file. I'll just call it certificate staging here. Staging .yaml, and again the API version same as before, cert-manager.kates.io v1 alpha 1, and the kind this time really is a certificate. Okay, again we need metadata, and for the metadata it makes sense to name these things after the domains that you want to issue the certificate for. So in my case it's a pretty long subdomain, and when I did a previous attempt on this I ran into an issue where the name was longer than 63 characters. So right now I'm shortening it a bit. It's just YouTube Let's Encrypt, and I'm leaving out the .kubucation.com part, but definitely adding the staging part here so that we'll know later when we want to switch to production. And that's it for the metadata. So now we need the spec here, and of course we have the secret name first. And the secret name, this is once we get the private key and the certificate back from the CA, which is Let's Encrypt in this case, we of course want to save them in a secret somewhere. So that would be YouTube Let's Encrypt staging, and then append TLS on the end. That was, by the way, Control-X, Control-N. I know that this question is going to come up in the comments, like how did you let Vim do the typing? And there's a great video by that same name, Let Vim Do the Typing, that I can definitely recommend. Other than that, we need to reference our issuer, and the issuer here was called Let's Encrypt Staging. And now the common name for our certificate is, now we need the full domain, YouTube Let's Encrypt.kubucation.com, and then a bit more configuration for the ACME challenge, basically to prove that we own the domain. And as I said before, we want to use the HTTP 01 challenge, and there we need to specify an ingress. I'll explain why in a second. And the domains that we want this challenge for is YouTube Let's Encrypt .kubucation.com, and just fix the trailing white space up here. And now let's go back to this line here. Why am I specifying an ingress here? So as I said before, we need to prove to the ACME API of Let's Encrypt that we actually own this domain. And right now we have an ingress running that exposes something on exactly that domain. So what cert-manager will do, and this is the coolest part about it, why everything is so automated, it will fulfill that challenge for us. It will add a second rule to this ingress to a specific URL, and that URL will then be contacted by the Let's Encrypt ACME API. And that is really incredibly cool because we don't have to do anything, and when the certificate has to be renewed, it will do that on its own as well. So let's add 3 dashes here, and let's see, maybe double check this time right away. Name looks good, secret name, staging TLS, Let's Encrypt staging, the common name looks good, so that's the domain. So I think everything should be correct. So let's apply this. Okay, we have applied it, so that means we should now do a get certificate. There it is. And again here, we should see events now. Okay, it has started this challenge. This is good. And I know for a fact that it takes GKE sometime between 4 to 15 minutes to update an ingress. So it'll probably take at least that time until we're ready here. So I can use that time to show you how our ingress has changed. So if I do a get inc nginx here minus oyaml, what you can see here is that there's all of a sudden now a second rule. And this is what I just explained. This is the HTTP 01 challenge that is being fulfilled by the cert-manager in the background, and we don't have to do anything. And how does it do that? It spun up a second pod here and is referencing that in that ingress. So that means if we now do a get pods, we now see 2 pods running here. So this one fully automated by a cert-manager, and this is, I just have to repeat this. This is really, really cool how well it integrates with Kubernetes. So coming back to our describe here, what we're really interested in is the events column, not column, but the section, events colon, and right now, okay, and of course not just that one, but let's say the next 20 lines after that. And now let's put a watch in front, because kubectl describe I think doesn't have a watch option on its own. And now we see preparing certificate, presenting challenge, performing self-check, and this will now take until GKE has updated our Ingress. And from what I've seen in my dry run, this will take anywhere between 4 and 10, or in extreme cases even 15 minutes. So I'll just sit back and relax and we'll watch a time lapse of this. Looks like we got an error here. Cool, so it looked like it failed the first time, but it requeued it and it succeeded the second time. I don't really know what exactly that error is. I tried Googling it, that's why I paused the screen recording in the meantime. Tried Googling it and I didn't really find anything, so I'm not sure quite what exactly it is. But after that, we got obtain authorization, issue certificate, certificate issued. So that means, and also of course a renewal is scheduled here. So that's another very cool part about cert-manager. Once your certificates expire, they will automatically be renewed. So now that we have that here, the only thing that we still have to do is we should now have a secret that contains our keys, but of course we have to tell our Ingress to use those TLS keys. So that means we should now have a secret. Let's check that. We do have a secret here, cool, and that secret contains our keys. So that means the only thing we have to do is add that to our Ingress. So let's maybe do a kubectl edit Ingress, and then nginx was the name of our Ingress here. And now under spec, we can add TLS, and that takes an array, and the first parameter is host, which is itself an array. And there we have YouTube, and again, we can do the control X, control N here. Yeah, that fits. And we wanna specify the name of the secret as well, so secret name, and that we called YouTube let's encrypt staging TLS, or was it TLS staging? I think it was staging TLS. YouTube let's encrypt staging TLS. Cool, so that means that if we do a describe inc, we should now see that it is pointed at that. That looks good. And now it'll take another 3 to 5 minutes for this to work. So if I try this now, I'm pretty sure it won't work exactly, but I'll be back after about 5 minutes and surely then it'll work. And then the only thing we have left to do is to switch to a production certificate, switch away from the staging API. And looks like now it's working. It does say not secure here because we're using the staging API, but I can accept that, of course. Cool, so that means the only thing we have left to do is switch to the production version. Then we'll have a trusted certificate and no more browser warnings. Luckily, that is really easy. All we have to do is copy our issuer that we had before. So we had this staging issuer, and let's copy that to a non-staging one. And then let's edit that and simply remove the minus staging everywhere. And I think the API is now, believe it is ACME v01, but I'm not entirely sure. Definitely have to check. The rest should be okay. And let's apply that. And if we now do a describe, if the API URL was correct, then we should now see, let's Let's maybe do a get issuer first. Then we should now see that an account was registered. So let's see, the account was registered with the ACME server. Cool, so that worked. So the other thing we need to do is our certificate. If we do a get certificate, we only have the staging one here. So let's also copy our certificate staging, same thing here. Let's copy that to certificate YAML and modify certificate YAML. And same thing here, we can replace the staging. And I think that should really be it already. Let's maybe double check. Name YouTube Let's Encrypt. Secret name YouTube Let's Encrypt TLS. Yep, looks good to me. So let's take a look at, oh, of course we should apply it. And now we can again watch for events. Before we watch for events, we can check our Ingress. Our Ingress should now have a challenge URL again. And it does, that's good. That means a challenge is going on. And now we can just watch for events. And again, the self-check is happening in the background. And last time it took about 4 to 5 minutes and then it failed. And then it took another 4 to 5 minutes to succeed. So this time I will not make any prediction, but let's just run this in a time lapse and see once we have our certificate back. Looks like we have an update, issuing certificate, certificate issued, and renewal also scheduled. So that means we have our real production secret and we can edit our Ingress again, called Nginx here. And there should also be, let me just search for staging. There it is, there should be a secret staging. So let us delete that. That was a bit too much deletion. Cool. And maybe just to double check that that was what the secret is actually called. Seems like it. Here, right, this one. So if we now do a describe Ingress, Nginx, we should see on the TLS part somewhere up here. Yes, that secret is now being used. So now the only thing we have to do really is wait for this Ingress to update, or for the external load balancer on GKE to update, because if I refresh now, it'll still say not secure, but that's really only a matter of time until we can see the secure badge here, and then we have a fully automatic obtaining of browser accepted TLS certificates with Kubernetes cert-manager and Let's Encrypt, which also happens to be the title of this video. And there we go. I just opened a new private tab here so that I don't have any browser cache, because I was expecting my browser to cache this. And as you can see, we now have a secure flag here, and the certificate says valid, and it was issued by Let's Encrypt Authority. So that's really how easy it is and how automated everything is, because the cool thing is, if this was now a production setup and I actually wanted to serve this content to someone, I wouldn't have to do anything. The renewal would be automatic, and basically this page would now have TLS encrypted traffic and have HTTPS in front and have this nice secure badge in the browser forever. So I hope you liked this video, and I think this now concludes this TLS and certificate series. And next I want to focus on some of the more core Kubernetes components. Especially, I've been planning for quite some time to do a series on the self-healing powers of Kubernetes. So make sure that you subscribe and don't miss that, and see you then.